Hello, welcome to Picture Me Coding. My name is Eric Aker. My co-host Mike Mull is with me today. Hi, Mike. How you doing?
Hey there. Happy New Year.
Happy New Year to you, 2024. We are back. This is episode 21, first episode in our second season. What's your life like in 2024?
It's been good so far. 4 days in now. I'll take what I'm getting.
Good sample size. I like it. Good indication for the new year.
Yeah. Already made a trip to Joshua Tree, so got that going for me.
That's pretty cool. I usually, at the end of the year, around November, December, get this hankering to just not work for a month or two. End of every year. I've been listening to this band called Sea Bear from Iceland, and they have this calm, nicely layered, soothing music. I've been listening to their album In Another Life, which actually came out in 2022. They kind of remind me of Belle and Sebastian, but they have this peaceful sounding music. It's nice. It's soothing. They have a song called Running into a Wall. And the singer sings, maybe in another life, I could be the husband type. I could see the sun explode. It's just like, this is good for my winter mood.
I don't think I understand that line, but for some reason I still like it.
Yeah. Just, things are happening and I'm going at a nice, even pace. Okay. So just leave me be. How about you? You got any music?
Yeah, so I tend to obsessively comb through end of year best of lists looking for stuff that I might have missed or ignored earlier. Usually find some interesting stuff. I've been kind of stuck on this one album that I came across on a couple of lists. It's by a band out of Dublin called The Murder Capital. The album's called Gigi's Recovery. It's described as post punk, whatever that means. But I think one thing I like about it is I'm there's a bit of nostalgia to it as well because there's some stuff on here that sounds like bands that I was listening to in the 80s. Um, in particular, there's a couple of tracks that remind me of Echo and the Bunnymen. Not sure
Wow.
if not sure if that was before your time, but
No, I remember. I don't remember them, but I definitely know who they are.
and there's one track that sounds very similar to some stuff that Peter Murphy did after he left Bauhaus and was working doing solo stuff. So anyway, I've been listening to it a lot, and I think anybody who's not an old man like me would probably enjoy it as just a decent rock and roll record. But I'm kind of liking the 1980s vibes.
Hmm. You don't have to be an old man to enjoy it, is what you're telling me.
No, it might help, but not required.
At the end of last season, we talked about moments at work that were embarrassments, things that we had done poorly. And we thought, well, maybe to save some face, we should talk about bugs we rooted out and solved. I had a couple that I brought for you, but I think you probably have some that are going to be surprising to me. A lot of my work has been in web and databases and infrastructure, cloud, stuff like that. What comes to mind when you think about weird bugs you've seen over the years? What's the first thing that comes to mind?
I'm going to do these in reverse chronological order, even though this one's
Well,
kind of old. So the
just give me one. Give me one, and I'll see if I even understand it.
so the first one I was going to talk about is a project I was working on where we were building sort of an enterprise tool, and it used Oracle as the database backend. And we had a prospect for the product that was a South Korean customer. And so our sales folks said, "Hey, can you make the adjustments to use the South Korean character set and where necessary?" And we didn't think it was going to be too big of a deal because we already had international customers and had adjusted to, German and French and things like that. So
Wait,
we,
can I ask? So does everybody get their own database and you have different character sets for each database?
yeah, in this particular application, every customer would have their own database. This was pre-cloud, so the database would have been something installed on their on-premise servers.
Okay.
For customers using, the Latin alphabet, it wasn't too big of a deal. Basically, the same character set, just different strings were used for, prompts and messages and things like that. So we initially didn't think it was going to be a big deal, but we made the changes that we would typically make to use a new language, and everything broke. Uh, pretty
Can you
much.
describe some of the breaking?
So this application essentially, the data in the back end was something like a list of ingredients for a product formulation, and the people using it would pull up a particular formulation, and then they would tweak it, and they could do what was called experimental design, to look at potential alterations to that formulation. And so, the interaction with the database was pretty key. And so the the application just basically did nothing when we switched the character set. It wouldn't even bring up the initial screens, and we thought that was kind of surprising just for changing the character set. I guess,
Seems pretty harmless.
yeah, I guess in retrospect, you have to take into account that all interesting bugs are either probably due to character sets or date times. In any case,
So how did you go about trying to debug this one?
so we this was a program in C++, and so I think we were using Microsoft tools. So we had a pretty good debugger and started tracing through the program, and we could pretty easily see that the initial problems were being caused by the client trying to talk to the database. Okay, so far so good, but it didn't look like it was doing anything different. We were just sending ultimately just sending SQL queries through the Oracle client to the database, and didn't really seem like anything was different than the normal situation. There was no Korean input or Korean strings that were being shown yet, so uh, it wasn't something that we thought was specifically due to the character set.
Your queries weren't in Korean, like
No, the
you weren't
no, the queries were
okay.
just straight SQL, and anyway, it was mystifying, and there was no significant change in the code, so it was hard to understand what was going wrong. And so after a couple of days, literally, of just sort of, drilling down deeper and deeper and deeper, I finally noticed that in memory, when you would send out a SQL query, there was a buffer that was being overwritten, and it was corrupting some memory beyond that buffer. And what it turned out is that, we had switched to Korean, which was a multi-byte character set, and as a result, the SQL queries were actually being sent in this multi-byte character set, but the Oracle client was not expecting that, and so it was filling up this buffer with I, I think it was actually the results from the query. It was filling up this buffer and using this multi-byte character set and just writing over the end because it was not expecting these multi-byte characters.
So it didn't have enough space in memory.
Yeah, it was just an oversight in the part of the Oracle client, which was not an open source thing or something we could change. So we did have to actually file a bug fix with Oracle for that. But
Hmm.
anyway, classic case of a very minor change causing a very large impact.
I have one that's similar. Happened to me last year, actually. We have an app that takes events and responds with these model predictions. And these things, they don't necessarily have to be real fast. I think the app was originally written with the idea that, well, if they get there in a minute or two, it's fine. They're not going to be immediately used by humans. And somebody came to me who had been working on this app and they said, "Hey, can you add open telemetry to this app?" And for those who haven't used open telemetry, the idea is that you can wrap calls that you make to external connected services. They might be databases, it might be other services. You can actually add some metadata to all these requests, and those requests will end up being chained together. So I can send out a request and I can add a tracing span ID. And then if I receive a request with a tracing span ID, I can say, oh, well, that's the parent request. And I can add a new ID to the request. And in this way, we can map them back together. It provides a lot of useful debugging information and information about how long things take. Anyway, so somebody comes to me and says, "Can you add open telemetry to this app?" And I thought, yeah, no worries. I've done that. At this point, I had done it probably 24 times to different applications. It's a matter of making sure that we add the right libraries. This was in Python, that we send the tracing spans out to a collector, and that we instrument things we want to instrument. And in this case, this app was actually talking to a SQL database. So it's useful to be able to instrument those SQL queries because then you can see, look, this one is taking a long time. Like here's one that takes a lot longer than we think it should, so we can optimize that query. Anyway, so I added OpenTelemetry to this app, and shortly afterwards, the person who asked me to do it said, "Hey, our app's going crazy. It's breaking. It's exhausting the database connections." And I was pretty surprised by that because I had added OpenTelemetry to a lot of apps by this point. It must not have been what I did. I couldn't believe it. It just seemed crazy that adding OpenTelemetry to this app would cause this crazy issue where database connections would explode. So I actually took a look at it, and I started using this tool a number of years ago called NetTop to debug connections made by apps. NetTop's a super cool tool. You give it a process ID, and it will show you all the network connections that process is establishing. Here's the IP address, and here's the port, and the protocol. It's pretty cool, actually. So I ran this project locally, and I used NetTop to look at the database connections as they're getting spawned. And every time you call a particular function, it would create all these database connections. And then as the function went out of scope, the connections would just linger. So it was like leaking somehow. So create a bunch of database connections, and then they would stay there. And if you called the function, you would get more connections and more connections. And if you switch back to the branch or to a git commit before my change, problem's not there. So somehow adding OpenTelemetry to this app made it so that it would just spawn database connections every time you call particular functions.
And you didn't want that, right?
I didn't want it to exhaust database connections. So this was actually not too hard to find out. Once I found out it was creating and reusing these connections and it was related to this instrumentation, I had to look and see, okay, where's the app creating database connections and how does the instrumentation library work? So actually the instrumentation library is open source. And what they do is they monkey patch the Python library that creates the database engine, and they wrap it. They have like a reference to it, and they wrap it with their own engine thing that now has the instrumentation added in. It's like, okay, there's something going wrong here. And after digging around a little bit more, I finally realized, you know what? It looks like there's a memory leak in here. They're creating a reference to this thing, and that reference is never going out of scope. It's a dangling reference, and so it never gets garbage collected. And ultimately, with those clues, I found a GitHub issue for the instrumentation library, and they said, yeah, exactly that. There's a memory leak. It was an open bug at the time. They fixed it probably a few weeks later. For our fix, I was like, you know what? I'll just make it so that these connections are created once globally because this particular app is fine with that. We'll create a connection pool that works globally, and then we won't need to create one every time this function gets invoked. I was so surprised that adding open telemetry instrumentation to this app could exhaust database connections. I mean, it made sense once I saw the bug, but I was just absolutely shocked that this innocuous change I made could have that pretty catastrophic result on the application.
That is surprising.
I really like NetTop though. NetTop's a friend of mine. Some of the tools I like to use are friends of mine.
Very good tool. Yes. Yeah, I had one that goes back to my Cray programming days. For the young folks out there, there used to be a company called Cray that made supercomputers. Those supercomputers are probably not as powerful as your iPhone, but they were pretty impressive back in the day. Somebody had asked me to look at this Fortran program, so there's a little bit of lore there too, since there are probably not that many people familiar with Fortran anymore. But yeah,
Fortran's pre-structured programming, right? So we still have go-tos.
it probably had some go-tos in it, yes. Although you could write structured Fortran pretty easily at that point.
Okay, all right, all right.
So there was this code. It was probably doing some sort of chemistry calculation or maybe fluid dynamics or something like that. And the person who wrote it was had ported it over from another computer and was all of a sudden getting incorrect results. And he couldn't figure it out, so he asked me to take a look at it. So I was looking at it, and it seemed like the answers started to go haywire after a call to this one particular function. But the function was relatively simple, and I couldn't figure out what it might be doing. So again, I looked at it, and there's a couple of details about Fortran that you need to know to understand this. One is that Fortran 77, which this was, everything was essentially passed by reference. So even if you passed in a scalar value, it was getting passed by reference.
Do you want to do a digression on that? Pass by reference, pass by value?
Yeah, so I mean, I guess you can think of it in terms of when you call this thing, you're essentially passing a pointer to the variable rather than passing the actual value of the variable, assuming that you understand the idea of pointers. In modern languages, if you were passing in, if you had a variable x which equaled 3 or something like that, and you pass it into a function, it's probably just going to pass it by value, unless in some languages you could explicitly say, I want to pass this by reference. But in Fortran at that time, everything was by reference. So another thing is that a Fortran Fortran had subroutines and it had functions, and functions were what you'd expect them to be. If you had a function called average or something like that, and you passed it in two variables, it would return you, a single value, which would be the average of those two variables, let's say, as an example. So you could only get a single value back from a function, but there was a trick that people occasionally used. Since the values were passed in by reference, sometimes to sort of trick the function into returning multiple things, people would pass in an extra variable and change the value of that variable to get a second result from that function. Bad practice, but people frequently did it.
So like a side effect thing. So it's like you give it your values, you give it an extra box, and the function's going to put something into that box you gave it.
Exactly. So I noticed after a while that this particular function was using that particular trick. There was a point where the variable that it was overriding, the value, instead of passing in a variable, the person was passing in the constant 2, the literal value 2. And
But was that a reference? It's a reference still? It has to be a reference, right? Because functions always work by reference.
right, most modern Fortran compilers at that point in time would have, worked around that. So if you passed in a literal, it would have done some magic to make sure that that wasn't really a reference. But this Cray Fortran compiler was, sticking very closely to the spec. So what was happening ultimately is that they would pass in the literal 2, and then this function that they were using would change the value of the variable that was being passed in as the literal 2. And then subsequently, anytime the literal 2 was used, like say you
It was,
squared a number, it
yeah.
was actually a different
It
value.
was using,
Um,
that's a pretty nasty bug right there.
yeah.
So you no longer have two. You can't use the number two anymore after you call this function.
You can use it. It just has a value other than 2. Um, so it was somewhat difficult to debug, but even more so after starting to get a hint of what was happening, it was just very difficult for me to believe. So
Hmm.
I probably spent close to an hour after starting to get this realization to convince myself that it was actually changing the value of a constant in the program, because that just seems so unlikely and weird once we removed that side effect and reprogrammed it a little bit, things started to work again. But kind of reminds me of that joke about how 2 + 2 = 5 for large values of 2. You know, could have actually been true. And
Did you have a debugger with Fortran? How do you debug Fortran?
at the time, there was a sort of primitive debugger that we had on the Cray. It was kind of like it was one of those things where you could set a breakpoint and you could print the value of a variable. Although I suspect I was likely just doing the equivalent of print statements. Also,
Print debugging?
yeah.
One time at KubeCon, I saw Kelsey Hightower. Kelsey Hightower is well known in the Kubernetes world for being one of the early contributors to the Kubernetes project. And he's done a huge amount of work to talk about advance and bring people into the community. So he was giving a keynote at KubeCon a number of years ago, and he, inspired by the film Hidden Figures, he built and deployed a Fortran Docker image that he deployed on AWS Lambda.
Mm,
That sounds potentially scary to me to debug.
brave, yes.
Brave, yeah. And he did it live in front of an audience. That's a Evil Knievel style live demo right
Yeah,
there.
flaming hoops and everything.
Yeah, very much so. Early on in my career, I did a lot of web dev work, and I worked for this news organization, and I often had to build these interactive features for the journalists who were writing stories. They would sometimes want a feature that would go along with their story. And we just called these interactives. That was the word we used for them. In California, we have these propositions that people vote on. And some years you have a lot of propositions, and they're confusing to try to keep track of if you're not, in that sphere of working on them, I guess. And so there was a journalist at this news organization, and when there was an election coming, she would write these articles about the propositions, trying to unpack them, trying to unpack who argues for and against them. And she had this interactive that had been somebody had written before me, and she was trying to update it and change the way it looked, and she wanted me to make some changes to it. Okay. So this is just simple JavaScript stuff. And this bug is nothing like your Fortran bug. It's pretty basic, but there's a lesson in here that I carried with me. So we had these, you can imagine like every proposition would have the title of the proposition, some of the short text of it, And then it was an interactive, so you could like click yes or no. And it had these little, like it was a blue arrow, I think, pointing up if you say yes, and a red arrow pointing down if you said no, as like a visual indicator. These are the ones you voted for, and you'd see the yeses in some columns and the no in some columns. I'm kind of embellishing a bit because I don't totally remember what it looked like, but that was sort of roughly what it was like. And it would keep track of the ones you'd voted for and the ones you'd voted against. That was basic of the web form, very basic JavaScript stuff. This is before Angular JS. This is in, jQuery was huge at this time. So it was either in vanilla JS or it was in jQuery. All of this interactive. There's no like that. There's no back end functionality. Very, very simple. And it's such a simple app. And everybody said, oh, this is working great. The changes you've made are great. It's fine. But the person who worked on this article, she's an incredible journalist, very detail oriented, fastidious person. Just one of those people who she cared about every comma. She would never let a detail go by without like making a note of it or questioning it or following up on it. Extremely like close attention to detail. It didn't work for her, the app, at all. And I was like, this is such a basic app. It works for everybody. Why doesn't it work for you? I just could not get it. I figured it had to do with event propagation and JavaScript because these were probably, it was either form inputs in this thing, or maybe they were divs. This is back in where we just had a whole bunch of divs everywhere. That was a big deal at the time. In JavaScript, when you interact with something on a page in the DOM, there are these events. Like you might click on it, there's a click event. And by default, those things bubble up until something says, yeah, you're done bubbling. And you can actually stop things from bubbling up with stop propagation. And, if somebody clicks a form and you want to submit it using JavaScript, but you don't want other things to happen that would normally happen with a form click, you will do something like prevent default. So I spent, maybe an hour like, what is wrong with this thing? There's got to be some weird JavaScripty thing we're doing that's preventing it from working. I could not figure out why it didn't work. And finally, I did the thing that I should have done at the very beginning. And this is the thing that I always end up wanting to do. I just walked over to her desk and I said, can you show me what you're doing? It works for everybody, but it doesn't work for you. And she said, well, it doesn't work for my boyfriend either. He tried it too. So again, it's like there's a box where you can click yes or no. There are these little arrows, blue and red. And then there's like the title of the proposition, which was bolded and big, and then a little bit of text. And it was like a row in, in many rows that go down the page. And she did a thing that never ever occurred to me. These little arrows were very small. And when she wanted to click on one of these things, whether she was voting up or down, she always clicked on the arrow. And it was really like meant, I mean, I didn't originally write the app, but it was meant as this visual indicator, like just so you could scan down the page and see these ones I voted for, these ones I didn't. The icon was so tiny, I was just completely surprised that she would bother to like move the mouse to click on that thing. It never would have occurred to me. When I use a mouse, I just click wildly all over the place until it lands close to what I want, and then I'm good. I click rows or text or whatever. When it comes to mouse work, I'm kind of a button masher. I'm not using a fine instrument, okay? I'm just getting close and smashing that button. She didn't do that. And as soon as I saw, oh, she's clicking the arrow, I immediately was like, oh, okay, that thing's not really wired up to listen to anything. That's why it doesn't work for her. It's a very basic app. It's a very basic bug. The thing that it taught me was I am not going to be able to anticipate what users are going to do with these things that we build. And that has continued to be true throughout my career. It doesn't matter what it is. You could build a thing and assume the 90% path and be, and maybe that's true. Maybe it is the 90% path. Be completely blindsided by the 10% path, by the people going through this tiny door that you didn't even know was a door.
Yeah, it's amazing how You can sort of live with something for months and then immediately somebody will do something you didn't anticipate.
It seems like a fact of software development that you can get so wrapped up in expecting it to work a certain way, and people do amazing and surprising things. They're not wrong, right? They're using the tool, and you can learn so much from watching people use the tool. That was early in my career, and I always have this hankering to just go and watch the people use the thing. And in some cases, you can do that. In some cases, you can't.
That's a good one. My last example is probably my favorite bug of all time. I have to admit that I caused it in addition to discovering it. So discovering and fixing it. But so this goes way back to the very early days of my computering, and there's probably some stuff in here that I will have to explain because there's some stuff that computers don't really do anymore that was common back then.
Cool. Archaeological.
Yeah. So I was working on this computer graphics program. That was kind of my first love, I guess, was computer graphics stuff. And this was really basic. It was mostly 2D, just shapes and lines and things like that. And it was something that I was writing on my own PC, which was an IBM PC of that era. So I'd been working on it for quite a while. And one day I started to notice this weird effect where I would add a new element to the picture. I would add a new shape or something or add a new line, and a row of pixels in the picture would disappear or it would blank out. It would blank out. And I was, initially I was like, oh wow, there's probably something wrong with my graphics card and this is bad because I, can't really afford to go out and buy a new graphics card. So it kept happening, and I finally decided, okay, let's see if I can. Maybe this is a bug, and maybe I'm drawing something wrong, and it's just writing over something that I am not expecting it to write over. So there's the two things that are probably going to be surprising to younger people. Are one is in that day you could do graphics by writing directly into memory. So on the early IBM PCs, they had an addressable space of 1 megabyte, which sounds preposterous now. But the uh, the video buffer was actually the upper part of that 1 megabyte, so you really only had 640 kilobytes that were usable by your programs, and then the, there's a part above that that was used for the video buffer, and you could literally write into that buffer, and things would show up on your screen.
Hmm. Sounds pretty quick, actually.
Yeah, it was very efficient. At least if you're doing, primitives, if you're trying to do 3D stuff, it was trickier since you had to do all those transformations in your own code. But this program was in C, but to make things as fast as possible, I was writing the graphics primitives in assembly language, 8086
Mm,
assembly language.
mm,
So I had assembly language routines that would draw lines and draw circles. There's a famous algorithm called the Bresenham's algorithm for drawing lines using pixels. These algorithms were, this is what they call rasterizing. So, you have
mm,
these horizontal scan lines on your computer, but what you're really trying to get is circles and lines. And so you have to go through this process of approximating a line with a series of pixels. So I would call these primitive functions from my C program, and that made the graphics considerably faster. So the lines would draw fast and the circles would draw fast. When you call assembly language from C, the first thing you'd have to do was you'd have to stash some of the registers on the stack, then do your various work, and then restore those registers.
um, why?
Because the the program that was calling your assembly language routine would also be using those registers.
Same registers. Okay. All right. So you got
Um,
to sort of be like, well, let me cache what we were doing, is what you're saying.
right. So, in particular, there was a register in the 8086 processor called the extra segment. This gets into some weird details about the strange memory addressing of 8086 machines, but suffice it to say that when it would enter into my graphics code, I would stash the extra segment on the stack and then alter it so that I could write into the memory buffer.
Hmm.
And then when my graphics primitive exited, I would have to pop the extra segment off the stack so that it would have the same value that it did when the caller called that.
So far, this sounds just like here I was playing with fire, and I was just about to add some gasoline to my play, and it seemed like everything was going great.
Yeah, pretty much. Yeah, that's that's about the form of it. Um, so the problem is that if you accidentally don't restore those registers, weird things will happen.
Yeah, I'll bet. Yeah, I'll bet that's true.
So you would think those things would be, sort of catastrophic or so serious that things would just horrendously break and it would be obvious that there was something going wrong. But what I was doing in particular is I was forgetting to restore this extra segment register, and the calling program was using that extra segment register to point to the C heap. So what was happening is when I was seeing these pixels disappear from my drawing is that every time I would add a new object, I would call malloc to allocate some memory for that object. But because I was forgetting to restore this register, it was actually allocating the memory in the graphics buffer. And this particular version of malloc would clear the memory when it allocated it. So
Mm.
every time I added a new object, it was essentially wiping out some of my drawing by mallocing in the video buffer.
So you were like working on your code. You mean your code was in operation? It was using the video buffer as part of its workspace, like its memory.
Exactly. And because of the mistake I made, it was using the video buffer as basically the heap. And
Yeah, it's hard to draw stuff to it when you're fighting over like, well, I need that to do my calculations. Video buffer. Can I just have a little bit of space? Okay.
yeah, for a variety of reasons, none of this would happen on today's machines. But at the time, it was, again, it was one of these bugs where in retrospect, it made perfect sense. But in the process of trying to figure out what was going on, it just seemed so improbable that it kind of took me a while to accept that that was what was
Hmm.
happening.
Yeah, it takes me a while to accept it. But this story and a number of debugging stories remind me of one of my favorite moments in The Simpsons. There's this episode of The Simpsons where at the beginning, Bart and Homer are hanging out together in the backyard and they've got this watermelon and they stuffed a bunch of fireworks in. And Bart's like, oh, I love our Tuesdays together, Dad. And then they like explode the watermelon with the fireworks. And then Marge pokes her head out the window and says, don't you guys have a bunch of chores to do? And so then they go in the house and they've got this chores list and they decide, wow, we can use fireworks to solve these problems. The first chore is like, I got to unstick this drawer and they put like an M80 in the drawer and blow it up. And Marge is complaining. She's like, I don't think you should do it that way. And Homer says, Marge, do you want the job done right or do you want it done fast? And she says, well, like all Americans, I want it done fast. And he goes, okay. And they just explode the drawer, the stuck drawer out. And she says, you know what? You can't argue with the results. So they go around doing chores with fireworks. And the last one, the grand finale, Homer says, is there's a stuck VHS tape in a VCR in Lisa's room, and they just have the face of the mouth of that VCR absolutely crammed with fireworks. And so they light the fireworks, and it creates this massive explosion and wrecks her room. And Homer says at that moment, this thing that occurs to me all the time with software. He says, wow, it's going to take a lot of fireworks to clean this place up.
Yeah, that's perfect debugging philosophy.
It's like, what caused the problem? Well, code did. So, what's going to solve the problem? More code. Definitely more code.
It's interesting how frequently that does sort of come into play where you're totally mystified by a bug. And so one of the strategies is just start breaking things and see what happens.
Well, I'm glad to hear some of these stories. It'll take me a little bit of re-listening to get too into the details of some of yours. I think I was listening to the C and assembly story, thinking I hope to never do stuff like this.
It was the golden age, man.
All right, I had fun. Thanks for telling me your debugging stories. We will catch you next week. This has been Picture Me Coding with Eric Aker and Mike Mull.
See you next time.
Bye bye.
Bye.